Mrs. Zenos here, coming at you with the Desmos Scavenger Hunt. This was assigned to my students to help them review the some really important skills that they're going to need on the Algebra 1 LEAP test. So this will be focused on Algebra 1 skills. Feel free to comment if you feel like there's something else that could be added, something that you've discovered. So the assignment for my students is they're going to see an example with steps to use specific features of the Desmos calculator. And then I'm asking them to recreate those steps on the slide that follows. So to dive into it, we're starting out with just graphing inequalities. Now this is a one variable inequality, and you can see the steps here. Type the inequality into the first row, identify the shaded region, and then the solution is going to be that x value, and it's also going to show them if it should be solid or open and which way the shading should go. So we're going to start by taking that equation, that inequality right there, and if you do click on these images, it will zoom in for you so you can get a better view. You can also change the zoom settings on your browser. I am always at 80%. But then you can get a better view of what it says. So we're going to go negative 5x plus 1 on the next slide is greater than or equal to, and then you can go back if you forget, x minus 5, and we'll see our inequality. And this point right here is our solution, and notice how it's solid and it goes to the left. So this shows our answer is going to be x is less than or equal to 1. And then you can grab the second one here to double check and make sure you have the correct solution. Notice that the shading flips here. It says greater than in the original problem, but there is a flip because we end up having to divide by a -1. And that's the first one. Moving on to the second one, we have rounding. So this is just a simple function in the calculator that lets you round to a decimal place. So you're going to open the keyboard in your calculator, click on Functions, click on Round. There are also other features, but we're focusing on Round right here. And then if you want to round to a whole number, you enter 0. So it's going to be round, and then your number, and then 0, 1, 2, or 3, depending on where you're rounding to. So we're doing 1.2358 on the next slide. Keyboard, Functions, scroll down, scroll down, scroll down. Round is under number theory. So this is a pretty big menu. You got to scroll all the way to the bottom around here. And what was our number? I don't know. It really doesn't matter. 1.23587.6. And then put comma. And you can put 0 for a whole number, 1 for the tenths place, 2 for the hundredths place, 3 for the thousandths place. And then you can just keep changing the numbers here to get more and more decimal places. So this could help a student who maybe struggles with rounding, but it's a cool feature. And I'm done with that one. You could also play around and put more numbers in there. Next is finding the greatest common factor. So it says find the GCF between these numbers, 36, 60, 24, and 48. And once again, we're going to be using the functions portion of our calculator. Underneath the number theory section, it says GCD, greatest common divisor, which is the same thing as greatest common factor. We're going to click on functions. We're going to find GCD, which is at the bottom of the menu. And we're going to find the GCD of 36, 60, 24, and 48 on the next slide. So once again, I'm opening the keyboard, clicking on functions, and we're going to scroll all the way down to find GCD. And what was it? 36, don't remember the numbers, just go back. 36, 60, 24, and 48. 36, 60, 24, 38. And we can see that it's 2. Or 48. Well, with 38, the GCF is 2. And then with 48, our GCF is 12. So just a quick way for you to throw some numbers in the calculator and get the greatest common factor without having to do it manually. Next slide. Table feature. Creating tables in Desmos and then creating just really how to make a table. We're going to click the plus sign, then click table, enter the table, and we can click zoom to fit so we can actually see our points a little better. Click and hold the color. You can change the color of it. So here we go. And next slide, we're going to hit the plus sign, click table, and then we can enter our numbers. And what were they? 0, 1, 2, 3 for our x values. Notice the subscripts, those matter. 0, 1, 2, 3. My favorite part is that it'll autofill those numbers for you after a little bit. And then 2, 4, 6, 8. Wow. For our y values. 2, 4, 6, 8. And you can also add other y values. So we can make a subscript for y2 and then add different numbers. So if you're comparing multiple data sets, you can add multiple columns for your y values, which I think is pretty neat. These subscripts are actually, if you just type y and then the number, it'll automatically subscript it for you, so you don't have to manually put it into subscripts. And then we can hit, where's the home button? It's okay. If you don't see, remember you can click and drag the graph around. You can use your scroll bar or here, home. Home will take you back to the center. But you can click and scroll around. Maybe sometimes some of these numbers get really big and you zoom out all the way. But that's it for that one. Next. Okay, so this might be my favorite feature of the Desmos calculator, regression equations. We can make linear, exponential, and quadratic equations if we have a table and some points, and using this symbol here called the tilde symbol to create your equation. We can use M and B, so this is for a linear equation. It gives us a table. So that process that we just used to make the table, we're going to do that again. But we have an extra step here. And then we're going to do the same thing for an exponential relationship and for a quadratic relationship. So 0, 1, 1, 4, 2, 7, 3, 10. Add table. 0, 1, what was it? 0, 1, 1, 4. Well, it goes 0, 1, 2, 3. I'm going to do the x values first because it will autofill those x values. And then 4, 7, 10. 4, 7. I'm just hitting enter to go down to the next row. And then on the next line, again, what I said about the subscripts, they matter because when you make this regression line, you got to use the same subscript. So y1, and then the tilde key, which you can find in the top left corner of your keyboard, just hold shift and hit tilde. This is also in the calculator. If you open the keyboard at the bottom, click on ABC, you'll find tilde on that bottom row, almost all the way over to the right. Right there is your little tilde symbol. Oh, I could do a double tilde. We only need one though. And then we're going to type in M for slope, x1, again, it's got to match the table, plus B. And there we go. It even draws the line for me, going through those dots from that scatter plot. And I can see my equation. The slope is 3, the y-intercept is 1, and if you're feeling extra frisky, just enter that y equals 3x plus 1 using those numbers from the regression parameters. And I can see that that equation matches the linear regression. I can turn it on and off. Next, after the linear, we'll go to the exponential. Same idea, make a table. And then our regression will be a little different. So in this example, it has x1 and y1, but I'm going to just add it. So for the second table, I'm actually going to use x2 and y2 because I'm adding a second table. Again, the subscripts matter. And look, it even automatically defaults to x2 and y2 for me. I just got to make sure that's what I use when I make my regression. So let's see. Our numbers are -3, oh, too far, 0, 1, 2, 0, 1, 2, and then my y values 1, 5, and 25. 1, 5, and 25. And I can turn off the other stuff just by clicking on the dot. I can hide that dots. I can hide that. I can hide that. Okay. And these are my new ones. I might actually just delete these just because I have to scroll down too far to see them. Okay, so my y2 table, and it's going to be, once again, y2 tilde, and then our exponential form was a times b to the x sub 1. So it is exponential, so we need to make sure we put that variable in the exponent spot. So we're going to write a times b. If you hold shift and press 6, that'll pop you up to the exponent spot. And we just type y or x2, and we can see our a and our b are 1 and 5. So this equation works out to be y equals, we want our a first, 1 times 5 to the x power. So when you actually write the equation, you don't need the subscripts anymore. Once you have a and b, you don't need your subscripts anymore. And so these match up perfectly. Now we have the exponential equation that matches the data points that we were given. All right, next, we're going to move on to quadratic. Scroll down, scroll down. Create an exponential equation, at least 3 points. At least you do need 3 points for the quadratic. You do need 3 points. So once again, we're going to create a table, input our values, and use the tilde symbol, and pay real close attention to the format here. Notice how it's in standard form. You can actually do this with vertex form and factored form as well. But we're focusing on standard form for the purpose of this example. X values -1, -3, -1, and 2. So let's go back. We're going to make a table. It says x1 and y1. That's okay. I already deleted all the other ones, so there shouldn't be any conflict there. And it's going to be -3, -1, -2. -3, -1, and +2. And then we're going to go back, and we're going to enter our y values, 14, 4, and -3.5. 14, 4, and -3.5. And you can see our dots. Do, do, do. Next line. Again, I want my subscripts to match, so I'm going to use y1 to match my table, tilde, and then it was a, watch this, this one has a subscript and an exponent, so I'm going to do x1, hold shift 6 to get my exponent and hit square. So it can do both. It can have a subscript and an exponent. I'm going to use an arrow to get out of the exponent, plus b, x1, that subscript has to match all of the x's I use, and then plus c. And now you can see a parabola that goes through those points perfectly. And we can steal the a, b, and c from our regression parameters to write our equation. Y equals 0.5x squared plus -3b, oh, not b, -3x plus 0.5. So I'm just stealing the a, b, and c from those parameters and putting it in my standard form. And now I can see my perfect equation overlaps with my regression data. Next slide. Ooh, lists and finding the statistics, mean, mode, median from our calculator here. So we're going to make a list. We're going to like L equals, and we're just going to list our numbers. 1, 2, 3, 4. It can be, whatever your data set is, that's what needs to go in the list. This is for univariate data, so this only works if you have one set of data. And we're going to click on functions again, so ranking as return, and then stats. And then it'll tell us on the next line, stats of L. So you had stats, and then you're going to put the name of that list. That was list L. So we're going to put that name in those parentheses. So here we go. I'm not going to remember those. Let's just start. We're going to make a list. L, and then it was equals, and then brackets. 1, go back, 2345, 2345, comma, I think it was 67, 67, and 890, comma, 890. Separate those numbers with commas. And on the next slide, we're going to hit enter on the next row for the next row, and then we're going back to calculator, the keyboard calculator, functions, and then we're looking for stats, statistics right here, and we're going to hit stats in the bottom right of the statistics section, and we're going to type our L for our list. And now we have our minimum, our first quartile, our median, our third quartile, and our maximum right there for us. And we'll make sure that that all matches by going back, double checking our work. 112.45, 112. Hey, perfect. Moving on to the next one. Fraction button. Oh, fraction button is our favorite, and this actually might be one of the simplest things you can do with a calculator. There's a little icon that looks like a fraction. So when you just enter a number, you can click that icon. So we're going to look at 3/9 and 0.75. So if I enter 3/9, which is an unsimplified fraction, and I click, it's just 3, and I'm using the keyboard here so you can see what I'm doing. 3 divided by 9 makes your fraction. Use division to enter your fractions. And then the second one was 0.75. So if we hit this button, it gives me the simplified 1/3, and then for my decimal, it gives me the 3/4. And you can toggle it on and off depending on what you need for your question. Try it out with other numbers too. Next, systems of equations. So we're going to recreate the steps below. They gave us a system of equations. We're going to input each question into the calculator. We're going to find the intersection point and identify the solution. So we have y equals 3x plus 5 as our first one. And then our second one, y equals negative 3x plus 2. Go to the second row, y equals negative 3x plus 2. And there are our two lines. If I click on this point where they meet, there's actually a little button here next to it that lets me pull that out, and then I can label it. And I can very clearly see the solution to this system is negative 0.5 and 3.5. Next. Systems of inequalities is our next one here. This process is very similar, except with inequalities, we have a little bit more than just one point. We have overlaying inequality regions here. So we're going to take these and we're going to we have a y is great. So these are the same too. So we have inequality symbols instead of equal sign. So y is greater than 3x plus 5. I can see that it's dashed. I can even get creative with the colors by clicking on the gear, and maybe I want to use purple. Maybe I want to use purple and not red. And then I'll go back. Second inequality, y is less than or equal to negative 3x plus 2. Y is less than or equal to negative 3x plus 2. It's red. I kind of want it to be black. Ooh, black and purple. And you can see this intersecting region over here to the left of both of our inequalities. And then the rest of this is about finding the intersection of the shaded region. So we're going to identify points. Negative 2, 4, 2, 2, negative 1, 2, and negative 2, 8. So on the line, the third line, we're just going to put those order pairs. Negative 2, 4. And we see the dot pop up here, and we're going to click label so that we can see. Notice that it is, and the overlap between the purple and the black, it is a solution. This is a solution. You can rename it to help you keep track of what's what. And then we have 2, 2. On the line beneath that, 2, comma 2. And notice how it is not in the shaded region. So this is not a solution, not it, because it's not in the shaded region. And we've got -1, 2 as the next one. Too many parentheses. Now this one is on this dotted line. This one does not count. The dash line does not count as part of your solution space. Solid line does, but not the dead dash, the dashed line. Not it because dashed. So that one is not a solution. See, even it says here, nope, it's not. And then a -2, 8 is our last one. And you can just keep adding points like this. And this one, let's label it. You might have to zoom out to see it. Oh, it's up here. So this one does count because it's on the solid line. Solution, solid. It's on the solid line. So now you kind of have a quick way to see what counts and what doesn't count. Next. So this is one of the big topics in Algebra 1, finding solutions on a graph, basically taking two functions or one equation and turning it into two functions. We grab the left side of our equation, the x squared plus 2x, and we grab the right side of our equation, the 2 to the x power. And we put these in as two separate functions. This will let us find the solutions. So if you do the equation straight as it is on the leap test, it's not going to give you the answer. That function is disabled on the leap test. So if we employ this left side, right side strategy, then we can get two graphs and find those intersection points. So we got x squared plus 2x, f of x equals x squared plus 2x. And then the second one was g of x equals 2 to the x power. And we see we have a quadratic function and an exponential function. If we click on those intersections, now for problems like this, the only point that really matters is the x value because we're solving an equation that only has x. So our two answers are -2.1 and 0.57. The x value is what matters for problems like this. And I can even label it x equals 0.57. You might need a round depending on the question you're trying to answer, but I only care about the x values here. So again, left side, right side, make two separate functions, and then look at those intersection points to get those answers. Next, operations. So this one, operations with polynomials. You've got a subtraction, okay? A, B, C, or D. Now, if you're someone that might struggle with, maybe negatives often mess you up, and we got a multiple choice. So you can actually take all 5 of these expressions and put them in your calculator. The answer should overlap the original. Their answer should overlap, so they should match, equivalent, the same thing, equal to each other. So we're going to have 5x to the 7th power plus 7x to the 8th. I'm just going to enter that whole thing in there. Plus 7x8. It's going to enter the whole thing in there, 7x to the 8th power. And then it's a subtraction problem, followed by another parentheses, another polynomial. 4x to the 4th minus 2x to the 8th. 4x to the 4th minus 2x to the 8th. Make extra care to make sure you type this in correctly. Extra care. So 5x7, 7x8, and then 4x4. Oh, see, look. Extra care to make sure you didn't type the wrong thing in. And then 2x8 Yes. Now we're going to do the same thing with our answer choices. 3x to the 8th plus, so some of you might think, well, we just combine the like terms. That seems like it's so much easier. Well, yeah, it might be easier for you. But sometimes our problems require much more than just simply combining like terms. And so this strategy could be applied in different situations. Like if you have a quadratic equation and they want it in vertex form or factored form, this could save you time if you struggle with those concepts in algebra. My problem is remembering what was over here. You're probably going to struggle with that too. 7. 7x7. And so we can already tell that this is not an answer because it does not match the original. This one is definitely not an answer. It does not match. Look at this. Ooh, it definitely does not match. So I can go ahead and turn that one off. 3x8, 7x7. Nope. Okay, 12x8. And 2x4 minus 2x4. Again, it's making it red. I hate that it's defaulting to the same color, but I can change it to make it green this time. And zoom in and see, that definitely does not match. That is not one of my answers. All right, let's go to option C. 5x to the 8 plus 5x7. 5x to the 8 plus 5x7. 8. Hold that shift 6 to get the exponent there. And then the third term for that one was 4x to the 4th. Yeah, 4x to the 4th power. Well, we can now obviously see that one does not match. Again, I'll change the color. So I'll do purple. Well, I guess black. Those definitely don't match. That's not the answer. So notice how all three of these have not matched the original. Not once. So we're on to the fourth option, which by this point, process of elimination has to be the answer. But we're going to type it in anyway. 9x8, 9x8 to the 8th power, just so we can see what that final plus 5x squared. And the last one, minus 4x4. 9x8. Oh, 5x to the 7th power. Arguably, that is a little bit harder to read. And there we can see, let's change that color. So when I turn it on and off, you'll be able to tell, use yellow this time or orange, depending on your definition of what that looks like. You can see they overlap perfectly. This is our answer. The last one, answer D. This is just a strategy that you don't even necessarily need, but it's useful to have. Next one, evaluating functions. Yes, good old function notation. So we have three different functions and it says find f of 2, g of -10, and h of 100. Notice that those letters correspond to the names of each function, function f, function g, and function h. So we're going to start by entering our functions. Make sure we copy them exactly, and then applying that function notation. So 3x plus 5, f of x equals 3x plus 5. Some people also might be familiar with the fact that you can just make a table here, and it'll do the same thing. But we just want to use f of 2. Type it in those parentheses. F of 2 is 11. F of 2, 11. So what we get on our slide should match what's over here. So g of x, x squared plus 3x minus 75. Equals x squared plus 3x minus 75. And we double check. Make sure you type the problem in correctly. Yep, and we're doing g of -10 on the next line. G parenthesis, -10. There's our answer, -5. And then for the last one, h of x equals, we see right here, h was 1/2 times 3 to the x power. So this one is an exponential. So we're going to do 1 divided by 2. And then make sure you're out of the denominator using the arrow keys. Parenthesis, 3, close parenthesis, to the x power. Hold shift 6. Hold shift, press 6 to get that exponent. And then for this one, we're finding h of 100. H of 100. So next line, h, parenthesis, 100, get a really big number, times 10 to the 47th power. That makes sense. It is exponential. And you can even zoom out and look at those graphs a little more clearly if you want. You have a exponential, a linear, and a quadratic all hanging out. It's one big party. Next, average rate of change, slope. This is all about slope. So you're given a function in an interval. It is important to note that this interval applies to your x values, is your start and your end. So this one is going to start at -3 and end at 5. And we have a function right here. So we're going to put in the function. We're going to find f of -3, our start of the interval, to get, t, the function t, and to get the output or y value. Then we're going to do it for t of 5. We're going to find the input when it's 5 again. Notice that those numbers are the start and end of your intervals. And then your final step will be to take those points and put them in the slope formula. So let's do it. T of x equals 2 times, this is in vertex form, x plus 3 squared minus 5 squared, I got too many parentheses, squared plus 5. Oh, I don't see it, so I can zoom out. There it is. There you are, parabola, trying to hide from me. So make sure, minus 5. Again, make sure you enter the problem correctly, -5. And then we need t of -3. T of -3, it gives me 5. And then I have t of 5 for the next one, for the end of my interval. So we have our x value and we have our y value. So we're going to take these numbers and that's what's going to go in our slope formula. M slope equals, make a fraction. If you hit the division symbol first, that'll make the fraction starting out. And then we're going to subtract those y values. Make sure you do minus -5. That is a double negative. And then I'll do 5 minus -3. Notice how the 123 and the -5 are on top. The y values go on top. And then 5 minus -3 went on the bottom, and it gave us 16. Let's check our work. Hey, nice. Good job. Next slide. Quadratic formula. Ooh, yes. Notice it says must be in standard form. To apply the quadratic formula, it must be in standard form. So first we're going to enter the plus version of the quadratic formula and then the minus version. Your calculator's not going to do plus or minus. You do have to write it twice. And then we're going to put in what a, b, and c are. That comes from the equation itself, -16, 20, and 6.83. So here we go, entering those quadratic formulas. So first, x equals, again, hit the division symbol or the slash symbol to start your fraction first. I see a lot of students mess this part up. So you can use the keyboard, and then we're going to have -b plus, the square root symbol is right here. You can also type SQRT, pop up for you, b squared minus 4ac. Make sure that discriminant, it's called the discriminant, all of that is under your radical. B squared minus 4ac. I see a lot of students mess that up too. That entire thing should be under the radical. And then you can click or just arrow down 2 times a. And look, it's even already asking me. Now, on the leap test, it's not going to ask you for the sliders. But we're gonna hit enter. Look, it did it for me automatically. Go. Oh, wait. Not what I need. We're just gonna click below and we're gonna do the same thing. Hit that fraction symbol first and then negative b. But now I'm gonna do minus. I got one that's plus and one that's minus. Square root. B squared. Everything else will be the same. B squared minus 4ac. Arrow down over 2a. Look at it trying to put in those sliders. And then our problem had negative 16, 20, and 6. So we're going to put a. We're not going to use the sliders because we can't use sliders on the test, but we can just type in a equals negative 16. Hit enter. B equals, what was it, 20? 20, and then 6.83. B is 20. C equals 6.83. And look, once you have entered your values for A, B, and C, you see your answers pop up right here. Our two solutions are these numbers, negative 0.2791, blah, 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 and 1.52. These are definitely irrational. Notice how you can't change them to fractions because they're irrational. And let's double check our work over here. We got the same thing. Perfect, perfect, perfect. All right, next. All right, so making a table. This is a different way to make a table, and I actually touched on this earlier. If you enter your function and then create the gear and click table, it's going to make the numbers for you. It's going to make the table for you. So we have 5x squared plus 2x minus 4. And I actually don't think I need the function notation. 5x squared plus 2x, double checking, don't trust my memory, 2x minus 4. Hey, okay. And then if you click on the gear, click on table, and it makes a table for us. It even plots those points on the function, on the graph itself. And I can compare these two side by side. This is a great way to find x-intercepts as well. This one definitely has irrational roots, irrational x-intercepts. We have a y-intercept right here at negative 4, which matches our standard form. And we can also add a number to this table. Click next to the last x value and just hit enter. Enter, 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 and we can get more numbers just by hitting enter. If you want negatives, you're going to have to go above the last one, and then we'll put negative 2 here, negative 3. If you want to go in the other direction, it's a little more complicated, but not bad. Then I can see the left and right behavior of our parabola. And we'll go back to our steps. Did we miss anything? Ta-da! Like that. I did that. You're welcome. We're almost done. Last one. So this is the top of the mountain piecewise defined functions. So these are basically a bunch of functions that have been chopped together and put into one function. Imagine like a collage. Take a bunch of pieces and you put them on one, glue them all to make a collage. So we have our steps here. So this piecewise has 3 parts, and we're going to enter each part separately. So the first one is 3 if x is less than negative 2. So we're going to write y equals 3 with a bracket. It even shows it right here. More typed out in a typed out way instead of just a snip. Bracket, curly bracket, x is less than negative 2. So we're going to go to the next slide and we'll write y equals 3, curly bracket, x is less than negative 2. And then I'm going to go back and make sure I read that correctly. Yes. Double check it looks the same. And then there's our first. So notice how it only gives me this part right here. It started out as one horizontal line, the whole thing. When I put in this domain restriction, that's what you're looking at here. When I put in this domain restriction, it chops it off, and I only see the numbers that are less than 2. Not even 2 is included here. Everything less than 2. Like 2 doesn't actually have a dot right here. It's everything. So 1.99, 1.98. Next, let me go back to second one. x minus 3, so our second one is x minus 3, but we want from negative 2 to 2. So x minus 3, y equals x minus 3. So notice I'm going to change the color. I like doing different colors here so it's easy to see the difference. Notice how this gives me the full line, the whole thing. But we're going to limit that domain. We're going to use a curly bracket. I just realized something. You're probably like, no, it's negative 2. You put 2. And you were right. This should be negative 2. Which, notice how it moved it over here above negative 2. Sometimes we learn from our mistakes. And then this will be negative 2 is less than or equal to x is less than 2. Yes, you got to pay very close attention and make sure you're using the correct inequality symbols. Let's double check. Negative 2, 2, negative 2, 2, and look, it's matching this right here. So we have the left part, the middle part. Let's go back. Hey, look at that. Tiny little piece, starting when x is negative 2 and going to when x is positive 2. So positive 2 is actually not included on this one, but negative 2 is. This one does have a dot at negative 2 because it's equal to. This one does not have a dot at 2 because it's not equal to. Notice how it won't even let me find a point there because it doesn't exist. Third piece of our piecewise is y equals negative 2x. Y equals negative 2x if x is greater than or equal to 2. Third line, y equals negative 2x, curly bracket, x is greater than or equal to 2. Ooh, and I think it's supposed to be positive, or did I do it wrong? Oh, it's negative. Nice. And look, it matches. It's all the way down here. Boop. And again, I like to do different colors, so let's do green for this one. And so this line starts when x is 2. If you click on it, you can drag it all the way up and see we do have a point at 2, negative 4 because it's equal to. And if you zoom out, it keeps going forever. There's no end to it. So we were driving along, doing pretty well, and then the road broke off. We fell onto here and then jumped onto this one. And you can play with it. Try different. Let's try making this x squared. Ooh, it's only given us the second half. Let me make it positive x, positive 2, and it flips it up. So try playing around with different ones of these, changing the domain. Like if I made this 5 and made this one 5, notice how it changes the overall appearance because we're only using little sections of each graph instead of the whole thing. There we go, like that. Very nice. And that is the end. So make sure after you've done every slide, you click hand in. That'll give your name a little check mark next to your name in the Desmos activity, and I'll know to go grade it. All right, please feel free to email me, ask questions in class if y'all need anything. And happy Desmos.